Yeah. So one more thing we say. What is that? Electrical standards. In electrical standards, your RS-232 will operate at voltage from -12 to +12. In olden days, it was -25 to +25. That was the operating voltage. And your microcontroller used now also it operates at 0 to 5 volts. So you cannot connect this RS-232 cable directly to the microcontroller. If you connect in +12 volts or +25 volts. So you need a voltage level shifter which converts logical understanding of RS-232 to the logical understanding of microcontroller. What do you mean by logical understanding? What is the definition of logic 1 to microcontroller? What is the definition of logic 1 to the RS-232 signal? What do you mean by logic 0 here? Logic 0 here. So that voltage bracket need to be mapped. That need to be mapped. That is why we use an IC called as MAX232. It is a voltage level converter. Okay. So whenever we interface RS-232 to the normal TTL, the devices, TTL are all our devices, whether you studied in the DEC or like whatever we studied in microcontroller, all of them will work in TTL logic, transistor logic, 0 to 5 volts. Right? This is what we have discussed yesterday. Today we'll go and see a program to send the data from 8051 to the outside world, whatever might be the external device. External device can be another 8051 or like your GSM modem or like a computer itself. A computer connected to the 8051. 8051 continuously sends the data to the computer. It can be anything, right? Another 8051 or a GSM model or a computer by itself, or it can be anything. If it does not understand your protocol, is it clear? Right? Today we will discuss particularly on that. So, in our yesterday's discussion, where we ended yesterday's discussion? Start bit, stop bit, data format that we discussed, right? Right? Okay. So, what we say right now? Okay, 8051. How UART is there in 8051? Right? 8051 IC has a UART module now, UART communication understanding. What do you mean by that? What are there in this? UART needs first 3 pins communication actually. 3 pins, TX pin, RX pin, ground pin. Ground you leave off it. Ground you can connect it anyway. TX, RX pins are mandatory. What are your TX, RX pins on 8051? TX pin 16, 10 and 11. RX pin. Receive data, transmit data. Receive data, transmit data. What is the port number value? Port 3.0. Ah. 1. Right? Okay. You should know this now. We have discussed everything apart from port 3. That is why we started discussing on the port 3. In port 3 we have done with T0 and T1 now. Only 2 pins were there. 2 pins we have finished. Another 2 pins are the serial for TXD and RXD. Another 2 pins are INT0 and INT1. Another 2 pins. 6 aitala. Read and write. Read and write. Read and write we have logically discussed in the end of the first chapter. How do we interface the external memory to your 8051? We have discussed in there. So if we discuss this, another 2 pins will remain, interrupt pins in INT0 and INT1, that we will discuss in the coming classes. Okay, right. So with this, like we have for the timers, T0 and T1, we have Tmod and Tcon register, setting a mode and controlling the timer registers. We have 2 two registers, TMOD and called as SCON. SCON. It again has 8 bits. What it does we will see, and then we will go to the next discussion. 2, 3, 4. Okay. It has SM0, SM1, SM0, SM1, REN, TV8, RB8. All right. SCON is an SFR register. In SFR, what is the address? 98. 98. Okay. Right. In this one is 00. This bit we will discuss later. Right now you observe SM0, SM1. Balaji went to sell the t-shirt. Not during the class hours. I thought I will buy one t-shirt from him. If you bunk the class and go, like, how can I buy? Right. Guys, listen. In SCON register, if we set this to 00, what is SM2 we'll discuss, hold on. If we set this to 0, 01, 10, 11, modes possible. In this mode, I think these two are 8 bits and the remaining, okay, that is 8 bit also. Register mode. Close the door here. Bit shift register mode. What is this? We'll see. We call as mode 1. Sorry, mode 0. In mode 1, it is 8 bit UART. That is plus 1 stop, 1 start, 1 stop and 1 start. This is what we have discussed. 8 bit UART, that 8 bit data form data, 1 stop bit, 1 start bit and 1 stop. And then like 2 and 3 are 9 bit formats. 9 bit formats with 1 stop and 1 start bit. Okay, with this there is one more very important information which is not there in your textbook. Please write this also. For this one, mode 0, it is oscilloscope, sorry, what is it? Crystal oscillator frequency divided by FCLK. FCLK divided by 12. FCLK divided by 12. For mode 1, it is timer 1 which decides the operating frequency. Guys, listen to this. When I say operating frequency for the serial communication, it is nothing but how many bits I am operating. The communication frequency is 9600. We will call that as normally as baud rate. Now in this discussion, you understand that baud rate and bits rate are same. Bit rate is bits per second. How many bits per second we are transmitting? Okay. So this communication speed for mode 1 is controlled by timer 1. The communication speed of the mode 0 is clock divided by 12. 2 is controlled by clock divided by 64. Again, last one is again controlled by timer 1. Okay. you got this? Did you got this? In this all modes, only this is there in your syllabus. Communication happens. We will not complicate the other parts. It is very, very simple. By default, if I want to communicate from one microcontroller to the another microcontroller, what is the easiest possible way? That will discuss. Okay. So we have to concentrate on only this mode, mode 1. Mode 1. The remaining modes are not to be discussed. They are required in many cases, but not in the cases that are there in your syllabus, or not in the cases of, by default, it is mode 1. Easiest way is mode 1. Throughout the world, when you say UART, and then you say press reset button, then it comes to the default condition. UART in 8051, UART in the GSM modem, or UART in the PC, it will come to the default condition. These default conditions are fixed. Then, like in that condition, it is timer 1, 9600 baud rate, with one stop, one start. There is hyperterminal in the HP computer, like XP computer. Windows XP used to have the hyperterminal. Hyperterminal is a communication, listen to this very carefully. Hyperterminal is a terminal software or a software which will give you all the ports information of your system. Your computer is there, this one. It has a bag, like there are a lot of ports. One port going to the keyboard, one port going to the mouse, another port going to the Ethernet, another port is going to your RS-232. All these ports are there. Whatever the data goes from this computer on those ports can be observed using hyperterminal software. You're getting what I'm saying, right? What is this computer is communicating out or receiving inside on these ports can be seen using that terminal software. One such terminal was hyperterminal, which was inbuilt in Windows XP. Windows 7 and from the higher version, they have configuration first. You just say restore to default. When you say restore to default, this is what happens. 9600 things, one start bit, one stop bit, 8 UART bit. You can see that. You're understanding what I'm saying? This is what I mean by default thing. By default, throughout the world, people have accepted this will be the standard. Is that clear? Is that clear? Right. Is there any doubt now? Is there any doubt in this concept? In all the modes, this is only there in your syllabus, that is default settings. Okay? Right. Now what you have to do? Yeah, this is about SM0 and SM1. This is about mode setting for the communication. In all mode setting, you have to use mode 1. SM2. SM2, you write somewhere SM2. Here SM2 as 0. SM2 as 1. 0 is normal mode. SM2 as 0 is normal mode. SM2 as 1 is multiprocessor mode. SM2 as 1 is multiprocessor mode. Multiprocessor mode. 8051 using the 8051 connected to 8051 module 1, module 2, module 3. Then on the same cable you can use this. But again, this is not there in your syllabus. By default, it is mode 0. SM2 is 0. This is the default condition. You can write here set to default. By default, it will be 0. So keep it 0 only. Okay. Next, REN. REN equal to 0 and REN equal to 1. When you make REN equal to 0 is by default condition. It will be 0. That means your UART is ready to transmit, not ready to receive. You're understanding? Your module, it is only there to transmit. It is not to receive. Okay? If you should also be sending a data and also receiving a data, then you should make this as 1. Okay? So, REN equal to 0 and REN equal to 1. When it is 1, it receives the data. What should be exactly said for that? Enable RX. Easiest way to say that. Enable the reception. RX you understand, right? Enable the RX is enable the reception. This is disabled. Okay. Next, TB8 and RB8. TB8 and RB8 are used in mode 2 and mode 3. The easiest way to avoid is this. Are used in mode 2 and mode 3, which is not there in your syllabus, so don't worry on the RB8 and TB8 and RB8. They are not in your discussion. Whole syllabus, they will not come into the picture. They are used when it is a 9-bit case. Guys, listen to this. I'll just tell you for your information. Has to be 1 always. In spite of start and stop bit, 9th bit has to be 1 always. When it is 1, you are transferring, TB8 will set. When you are receiving, RB8 will set. You getting what I'm saying? When you are transferring a data of 8-bit, the 9th bit has to be 1 always. In mode 2 and mode 3. Okay? That one, when you are transferring a data, that one will set the RB8. So as it is right now, we are not discussing on mode 2 and mode 3, which is, according to your syllabus, it is not there. So we will not worry on this. This is just for your information. What is this TB8 and RB8? It's a 9th bit setting when you are transmitting. When you are receiving, the 9th bit will set this. Next, 2 flags are very important. RI and TI. What is the first one? TI flag. One second. This is, you write it here as set or clear by software. This has to be set or cleared by software. You know what is meant by set or clear by software? What is that? Yeah. For example, TR0 bit. TR0 will stop the timer. Software instruction has to be given to set this and reset this. Right? Similarly, if I speak about TF0, hardware set, software clear. You don't need to set it. It will set by itself when it overflows, but need to be cleared by you. That is why it is CLR TF0, we have to write an instruction. You know this concept? Clear? Right. So this flag is also same. Hardware set, software clear. Both RI and TI, RI software clear. Hardware set and software clear. Okay? What it exactly does? I will write here at the bottom. Please observe very carefully. We'll discuss TI flag only, but that is in particular here. The two 8051s, I have named them as A and B. Now if I want a communication to be made between these two, this RxD will go to the TXD here. This TXD will go to the RxD here. Transmission here is a reception here, right? The transmission here is a reception here, right? Now you see this. If you, guys listen to this. If you want to transfer any data from module A to module B, put it in the S bus. Set the timer, it will go. Right? When it goes, that means when it transmits the last bit, the TI equal to 1 and then goes out. Last bit, that means whatever the job assigned to this is done. To say that, it will set as 1. So when TI is 1, what do you understand? Whatever I have put in SBUF has transmitted. So I can put the next value. Is it clear? Is this clear? Similarly, when you are receiving, once you received all the bits to SBUF, last bit also received, has to go. The last bit is stop bit. If that comes in, then like RI flag by itself, indicating that reception is complete. Reception is complete. So I can read this SBUF into A. You know how to read. Move A, SBUF will transfer the SBUF value to A. Are you getting what I am saying? So TI and RI flags, I will write RI here also. TI here. TI is set when transmission is complete. Is it clear? Right? Huh? No, not possible. It is 8-bit data only. The mode is set, it is standard. No 4-bit concept. Even if you are sending 4-bit, another dummy 4-bit you have to send. It has to be 8-bit format. Guys, is there any doubt in this concept? Please write this. These diagrams, this combination of discussion is not there in a single time. After writing this, we will write TI flag and RI flag. Please finish it fast. Done? Bharat. Huh? 1 TXD to RxD. No. If you want to only transmit this, you are setting it as transmitter device, this you are setting it as receiver device, then only one device is enough, one wire is enough. That is what happens in GPS. GPS also has a UART. The 8051 also has a UART. But GPS is always a transmitter. There is no receiver in GPS. GPS does not have anything to receive. So GPS takes the satellite value and gives it to the continuously to the microcontroller. GPS, RxD in this one has to be connected. Only one wire is enough. Is it clear? Right. So shall I rub this part? Now you write TI flag and RI flag. TI is right now with this one SBUF, it is difficult. There is one more SBUF, it is easy. There is only one SBUF, right? We have only one place to keep the things. If there is one more place here, if you want to give me, keep it there. But there is only one SBUF. Right guys, next right, TI flag. TI is transmit interrupt flag. TI refers to transmit interrupt flag. Set by hardware, cleared by software. You have written that. TI refers to transmit interrupt flag. Set by hardware, cleared by software. Cleared by software. Hardware sets it, but you have to clear by force. TI sets. TI equal to 1. TI sets or TI equal to 1. One and the same meaning. TI equal to 1 when 8051 finishes transfer of a byte, or Ti equal to 1 set by on hardware, Ti equal to repeating sentence, but write it, it is worth to write. Ti equal to 1 is set by hardware at the beginning of stop bit at the beginning of stop bit in the UART format, UART data format, in the UART data format. When it is both the statements are same. The first statement says when it finishes transmission. The second statement says it sets when stop bit is 1. At the beginning of stop bit is 1. That means you have transferred your data. Start bit, all your this data is went. The last bit is stop bit. When stop bit is leaving your controller, it will set the TI flag and then leaves. Is it clear? Right? Next one. RI. Same thing, we have to write it for RI. Receive interrupt flag. Receive interrupt flag. Software. Set by hardware, cleared by software. Receive interrupt flag. Set by hardware, cleared by software. Next, below that. Set by hardware at halfway through the stop bit. You got it? What is the meaning? Whenever data is coming in, start bit came, all 8 bit came, then like it is stop bit is coming. When it is in the halfway of making the full stop bit, right, it will set the RI flag. Stop bit will set the RI flag when coming inside. While going also, stop bit only set it. Right? Or when 8051 receives the complete set by hardware at halfway through the stop bit, or 8051 receives the complete data. You got the point? To summarize, TI and RI flag will be set when the job is done. When the given job is done. Transmission job is done, job is there, and when transmission is done, TI flag will set. Reception job is there, RI flag will set. Is it clear? Right? Next one. Now the very important part. In mode 1, this is there only this is there in your syllabus. Mode 1 should not confuse with timer mode 1. This is serial communication mode 1. SM0 and SM1. Correct. Right? When it is in mode 1, your XTAL is divided by 12, then like divided by 32 and given to the timer 1. Please write this. In mode 1, this is what happens. In mode 1, here baud rate, this you written, in bracket you write S mod is equal to 0. S mod is in PCON.7. Power controls, in power control, there is one more register called as power control register. In that 7th bit is S mod bit. That S mod bit is set to 0, then this is what happens. If it's set to 1, something else will happen. Something else in the sense like this will be double. Guys, you are listening to me. please, this one. Baud rates, these, these values are given. These controlling the frequency of the clock divided by 64, this divided by the 12 will happen when S mod is 0. S mod is peak on register's 7th bit. In SFR, like SCON, there is a power control. That is 7th bit is S mod. If that is 0, then this is what is default. So keep it 0. Or by default, T1. What will be the frequency at T1 if it is 11.0592 megahertz? Then what is the frequency here? Divided by 12. 921600, lah. 921600 hertz. Divided by 32. 28,000. 28,000 only. 800. 28,000 hertz. Correct, right? Right. This will be the, guys listen. This is the one which decides the machine's one timer increment value now. This is the one which decides with what speed your timer counts. Right? So timer 1 has CH0 and timer 1 has CH1 and TL1. Right? If I operate, listen to this, continuously, right? We will operate this in mode 2. That is auto reload mode. Mode 2, right? Mode 2 or mode 1? Mode 2, mode 2. One is 16-bit mode. Mode 2, auto reload mode, wherein which we will give value to only TH1. TH1. Right? Now if I want the frequency of 9600 baud rate, what should be the value for a TH1? No? Right. Shall I rub this part? This part? What I was saying is, yeah, see to this. I want 9600 hertz as a frequency now. Right? Then like what should be my value? 28,800, right? 28,800 divided by some X value should give me 9,600 value. You tell me value of 6, value of X, B, 3, right? So this 3 will make the value FF minus 3 is what? FF, FE, FD. Right? Every time FD, FE, FF, C is the answer. C is the answer. C, D, E, F. C is the answer. Are you sure? FF minus 3 is FC. Are you sure? Okay, right. Now whatever you say, I will write that and go ahead. So what I was saying is this. Whenever your TH value, guys listen to this. In auto reload mode, what happens? Right, TL0 will take the TH value and counts it to FF. Once it reaches FF and overloads, it sets the TF flag as 1. TF1 as 1. This one will generate me 9600 frequency. This one will generate the square wave. If I check the TF1 signal square wave, then it will be a square wave with a frequency of 9600. You are getting what I am saying? Hey, 1 second here. The counter has to overflow, right? The counter has to overflow. Then it is 3 bits only. It is FC, correct, plus 1 FD. When it goes from FF to F0, sorry, FF to 00, then like TF flag will set. So plus 1 has to be added that. In that case, we have taken 256, but actually FF is 255. If you check our previous calculation, you know, nene. ಏನು ಬೇಕು ಬರುತ್ತೆ ಏನು ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ ಇಲ್ಲಿ ಬಾ ಇಲ್ಲಿ ಬಾರೋ ನಾನು ಕೊಡ್ತೀನಿ ಬಾ ಪೆನ್ ಕೊಡ್ತೀನಿ ಬಾ ನಿಮ್ಗೆ ಬರೋ ನೀನು ನಿಜ ಹೇಳು ನೀವು ಪ್ರೈಮರಿ ಸ್ಕೂಲಲ್ಲಿ ಇದ್ದಾಗ ನಿಮ್ಮ ಟೀಚರ್ ಹತ್ರ ಎಷ್ಟು ಲವ್ ಇಟ್ಕೊಂಡಿದ್ಯಾ ಹೊಟ್ಟೆ ಬೈದಿಲ್ವಾ ನಿಮ್ಗೆ ಪ್ರೈಮರಿಯಲ್ಲಿ ಹೊಡೆದಿದಾರ ಅವಾಗ ಸರಿ ಇದೆಯಾ ಇವಾಗ ಗೊತ್ತಾಗಿದೆ right guys you going it is FC plus 1 FD because after FF becoming 0 then your TF will set to 1. FC is the right value. FF minus 3 is FC, correct value. FF plus 1 we have to take because FF has to become 0. Is it clear? Is this clear? Right, done. Now what is the point? Did you understand this also? This is the frequency, or this is a signal which decides the speed of the serial communication. This is a signal which decides the speed of the communication. Now you say, I don't want 9400, I want 4800 or half of this. Then it has to be 6 here, right? If it is 6 here, then like what is the value plus that? Should be the value here. 6 value, it has to go back. F9, here. F9 plus 1 FA is the answer. Now I will tell you one simple trick. What we used to do is, we used to fix this and then we say like move TH1 comma hash 0xFA. Correct? Write it as hash minus 6. 6, right? 6 minus 6. Right? When you do write minus 6, what happens? 2's complement of minus 6 will be FA. Please check it quickly. 6 is what? 0, 0, 0, 0, 0, 1, 1, 0. 1, 0, 0, 1. Right? Plus 1 is 1, 0, 1, 0, 1, 1, 1, 1. This is what? This is F. This is A. Correct? So it is easiest way. Don't do this calculation. Just write minus 6. It will calculate by itself. Did you got this? It is the best way. Instead of FF has some value, then like that value will get, and then that value we used to put into this one. There also you can do like that. No. How can you do that? Like it is a 4-bit value. To take a complement, you have to split that into the 2 numbers and put it there. Then like you have to do like this only. Minus only for the 4-bit value. It is easy, like, right? Done. You are clear with what is inside the UART stuff. Inside UART, there is SCON and 2 registers are there. Both are in SFR register. SCON does control in what mode the serial communication should happen. What is the TI flag? When is the data is transmitted? When is the data is received? Whether receiver has to SCON. Sending a data is through SBUF. Receiving the data is through, that is 8-bit mode, 1 plus 1 stop bit and 1 start bit, and for that the baud rate is decided by timer 1. For that timer 1, it is divided by 32, added here. Previously we had only XTL divided by 12 things discussed, but it is divided by 32. This divided by 32 frequency is given to Twinsy as 9600. 9600. Then you have to divide this 28,000 divided by 3. This 3 is just 3 counts in timer. For every 3 counts in timer, it will overflow. It has to overflow and generate TF1 signal like this. This signal is the, right? Is it clear? Done? Right. Not there in textbook. That is why I am stressing on this so much. You feel it is easy here. When you sit alone, right, you will get n number of doubts. This TF1 is by default connected to the S box. It will only send bit by bit. Okay. Right now, if I have to write a program, TX program, UART 8051, transmitting a byte from 805 using a UART. What is the first step that I should do? What is the first step that I should do? ORG I know. Next, what should I do? Should I have to set SCON or timer? SCON or timer? SCON, yeah. TB8, RB8, then like SM2, all of them are 0. RI flag, TI flag 0. REN, you can make that also 0 because this is only transmission program. So you can keep it as 1, whatever your choice.